Today our guest is Gil Zilberfeld, and please tell me about yourself.
So, first of all, thanks for hosting me. Glad to be here. So, I'm Gil. I come to you from Israel, and I'm a trainer and a consultant about everything around software. I started programming at 10 years old, something like that. My grandparents went to England, brought me a ZX81, something like this, very small. And I started programming then. So, and I've been in software ever since. So, today I'm doing training and consulting about programming and testing and automation and DevOps and agile development, everything around this. I'm trying to help everyone who's trying to build better software, and I'm the author of two books: Everyday Unit Testing and Everyday Spring Testing, and also doing webinars sometimes. Just did one yesterday, and uh, I love to talk about it. So that's why I'm here.
Okay, please tell me about uh, TestinGil project. Who is it for?
So TestinGil is the company that I started, and basically it's for I'm trying to help everyone who's trying to, like I said, build better software. If it's programmers, we're talking about writing better software, clean code, teaching them unit testing, test-driven development. Um, Writing any automated test that they might, talking about the processes of design reviews, code reviews, people who are interested in agile, and most people should be interested in agile at that point. So about planning and estimation and doing retrospectives, basically monitoring whatever they're doing, whether it's Scrum or Kanban or whatever they're doing right now. Um, Concentrate on the results, like not just on the working with Jira or something like that. Um, Helping them work better, hopefully to enjoy what they're doing, and create better products that they could be proud of, that they can be confident that they will work.
Programmer, tester, team leader, project manager. What have the roles taught you?
So yeah, I've been through a lot of roles. I started as a programmer, became a team lead, then a project manager, then developer again. Can tell you it's all about people, even the technical stuff. So when I went back to being a programmer, for example, after management, um, I was like, after years of uh, managing people, both developers and testers, I decided that I want to go back to programming and become a better programmer. But found out about in a year later that it's okay. You can learn a lot of the stuff, but if you want to really learn, you have to work with people. So it's not like watching things on YouTube and learning from them. So have conversation, improve your people skill, and a lot of trial and error. So give an example about techniques and tools. I'm teaching a C++ course right now, and people are interested and okay. And there's a lot of discussion about the different features that we have in C++. One of them is multiple inheritance. And I have a friend that says that C by itself was a great language, and then C++ just made it a Frankenstein monster. So it's tools. You understand the tools. You need to understand what it's good for, when to use things, when what the problem that they're trying to solve, and try to have it solve for you the thing that that solves your problem. I think that clean code, for example, um, is it starts with understanding that other people will read your code, and it's usually not other people, it's usually yourself 3 days after you've written it. So you have people reading this, and you need to understand that they need to understand what's going on in your mind as you're writing the code. There's a lot of assumptions that you're trying to model into the code, and then make sure that they work. Sometimes the assumptions are right, sometimes the assumptions are wrong. But if you actually write tests to say, well, this should act like this, you actually write in code your assumptions. Therefore, if you give somebody else these tests, they can read it and at least understand what was the meaning of the code as you were writing it and your understanding of it. Now, that's the technical stuff. If you're talking about management stuff, um, I found out that these are things that you can also like grow into, because I was a lot of the time the smartest programmer, and then if anybody had a problem, they would come to me and I would solve it. And as a manager, I started doing that as well, but this led people to be being bored. Like, I solve their own problems. Why should I do that as a manager? So when I started to release and think about what's good for them and for good for the company, not just for myself, I saw a lot of growth out there. I think that the one of the things that are important to learn, both as manager and everything there, any role out there, is something called good enough. You need to understand when something is good enough and then move on to the next stuff, because there's a lot of stuff that we do that we can optimize and make better in code, in testing, in automation, management. But sometimes we don't need to, because there are bigger problems to solve, or what we're trying to solve is not really the big and important problem. So sometimes good enough is good enough, and then we can identify that and move on to other stuff as well.
You're a huge supporter of Agile. Will you tell us what you think is the best in this technology?
So Agile is a lot of things. People define it in different ways. A lot of people try to sell you Agile certificates and stuff like that. So when I started in Agile, it was like, I think 2004, like starting to look at these things, so pretty early in Israel. And actually, one of the first people who actually tried their hand in that in Israel. So what I was thinking then is what I'm thinking now. And a lot of people just looking at it and say, well, this is a process thing, doesn't have to do with software. And I don't believe that, because Agile, it's a word, but it's basically coming from a manifesto for Agile software development. So we're talking about software and how do you produce software. And the things that, if you want to like take a few most important things from Agile, is how to produce software in a consistent manner, and having always something that works. You can do something that I don't know, like 10% of what you were asked for, but it works. Like, you have tests to prove that, and you can show it to someone, the customer or the product manager, anybody, and they will tell you, is it's good enough? Maybe yes, we should continue this way, or maybe stop it. It's not what we're thinking, and we shouldn't have wasted all the time on building the other 90%. So always have something that works and that you can show. However, in order to do that, there's a price. We need to pay it. We pay it in good practices. So at the code level, for example, code needs to be readable. It needs to be. We need to be able to change it. So we need tests. We need automation in testing, automation in delivery, continuous integration, for example. Everything needs to be automated so we can actually focus on the things of building stuff and making sure it works. But that's the tool side. If you're talking about the people side, we said that if you want to do this consistently over time, because most projects are not over in 2 weeks, you need to write code in a way that people understand it. And the only way to write code, to make sure that people understand it, is have code review. So other people should need to look at your code and see that they understand it. If it's possible, do pair programming. I love pair programming. I worked a lot in pairs and in TDD, which we'll discuss also. So if you're working with someone on the code, you can't you can't leave the code without the other person understanding not understanding it. So the code is left clearer to both of you. Now, in order to do that, in order to change code, because you never write the code once and that's everything. It will be readable for everything. So you'll need to change it. And if you want to change it, you need to refactor it. And for refactoring without risks, you need automated tests. So it goes back to all these things supporting incremental delivery of something that works. Um, if you think about it, usually teams, even if you have developers and testers inside the team, there are a lot more developers there from testers, and developers can create a lot of code which testers have no chance of actually covering everything. So one of the things that Agile does, or it's not Agile that does it, one of the practices that we do is work as a team towards certain goals. So we need to plan together. So maybe the developers will not write all the code to make a generic product or something like that. But if the goal is to have one or two features working, we'll decide what is important in them working, and the developers can write that code and not additional code because they have time. And the testers can test this code. And because the developers already said, well, this is going to work, they wrote unit tests that actually test this thing. So when the tester get it, they can focus on system testing and not just returning bugs that should have been fixed in the first place. So having the conversation, having teamwork, people working together, and that actually focuses the team. So there's a lot about Agile that you can like take to what I believe in, but it definitely comes down to how we program, how we test, how we work as a team to actually work towards the goal. The goal is something that's working every 1 week, 2 weeks, or something like that. And all the technical things, all the process things support that.
Will you explain uh, simply in business language why TDD and especially writing automated tests is so important for the team?
Okay, so let's start with automated tests. Automated tests are a safety net for changing the code. If we don't have it and we need to fix something in the code, or we need to add a feature, we need to change the code. But if we don't have some kind of feedback mechanism that tells us, okay, you've broken something, oh yeah, it works, we won't know. And what we do in that case is that we say, well, we think it works, and let the tester find out if that's true or not. And that means that we kind of, every change that we do in the code is very risky. We don't like that. So we try to make the minimal changes in the code only where we think we will actually make sense in doing that, and that creates ugly code. And without tests, we don't even know if it works. So automated tests allow us to make changes to the code because we'll know if we've forgotten something. But it's kind of encouraging us to say, well, there's no risk here. You can do the code whatever you want, as long as nothing breaks, and we'll tell you because we have the tests. So it encourages you to do refactoring and improving the code. So it also uh, uh, makes it easier, less risky, encouraging to refactor to make code clear. In the end, you'll save time because we're talking about product coming out consistently, in a consistent manner, in a consistent time. So it saves us time. In TDD, in test-driven development, there's, first of all, let's explain what test-driven development is. It's a way to program first. it has the test name in it, but it really is a way to program. And you kind of write the test, a minimal test, and write the minimal code in order for the test to work, and then you refactor and do this cycle, which in a basically every, I don't know, 10 to 15 minutes you have another test working. Now, if you think about this, this is like a small scale of what I was talking about, building a product, like having consistently something that's working and adding things to it. So TDD is like that. Basically, it's the fastest way I know to develop software. And so small steps, and with every test that you pass, you feel confident that this works. And I talked about time and this thing. TDD is, I think, the biggest thing. It saves a lot of time on debugging, because if you have a bug and you start looking for it, you don't know where it happens. You're gonna spend I've spent hours and days working on bugs and trying to find where the problem is, and then reproducing it and then fixing it and making sure that I didn't break anything. With TDD, if you worked until now, you have like 10 or 100 or 1,000, it doesn't matter, tests that are working. And basically, you can come to a problem that you're working on the current test and you need to debug stuff, but you kind of develop like something like a spider sense from Spider-Man. You kind of feel if you get lost. So if you get lost, like you said, like you spend half an hour or even an hour trying to do the next thing, and you're not able to pass the test. Okay, so undo everything. How much code, how much time have you spent in the last hour? You haven't made too much progress. So a lot of the things that we don't do is that we've invested like 3 days of coding in this. We can't go back and just delete it. With TDD, it becomes easier because you don't make much progress until you say, well, it's done. Let's go to the next test. And the next phase is very short, so you don't lose a lot of time or a lot of code. So it's really a different way from what I've learned and what I've been taught to how to write software, really. And it's my default way of writing software.
Okay, please tell me what's the best thing about your job.
So, as I said, I'm a trainer, and I do consulting, which means either work with people and be part of their team, or teach the team how to work better. So the best thing is that, like, I teach people a lot of things, but a lot of them can be taught on the internet, on YouTube, or something like that. It's how-tos, how to do this, how to do this. So that's cool. But when people actually get why do you do this, when they say, well, this technique is good here but not here, or I'm going to use that for my thing because I know this solves this kind of problem. So when people actually get it, why they're doing stuff, and can tell me and can tell other people what made this work, and why is that important for them, that's the cool thing.
Please tell me about your uh, darkest elements in your job.
Okay, so mostly there's no like dark element. Like, I'm teaching people a lot of the time. People learn, but they say, well, it's not relevant right now or to what I'm doing, and that's okay. And you can take that also to, well, people don't tell me, and they kind of stare at me and say, well, they don't say anything, but I can see that, yeah, it's boring or it's not helpful for them. But that's okay, because I believe, like, I'm opening a door, and the door will always be open, and when they will be ready or they find the right context, they'll be able to go through that door. However, there is something else that might be more problematic, because this is like technical stuff, how to do things. I'm teaching them, they might remember it, that's good. But when I talk with managers and they don't take advice or they don't listen to feedback, something like that, that's not a problem for them. It's also a problem for their teams. And that's what I don't like. Doesn't happen too much because I work with people who are open to advice. They come to a point where they say, "Well, we want to learn, we want to be better." So that's why they call me. So I work with them, and they sort of listen to the advice. But I had in my history a few that it's not that my advice is gold or something like that, but the repercussions of that was not very good. So and so I think of it as personal thing. Okay, so it's an invitation to learn, but if it has side effects on their own team, like this is a problem.
What would you advise my audience about learning code?
So first of all, I would say learn to code. Um, Programmers, obviously, but also testers who are what we call manual testers or QA. We have different names for that. Um, we might think of programmers as people who are born programmers, or they will have an instinct for programming, but that's bullshit. Everybody can learn to program. Okay, it's a set of skills, it's techniques. Nobody's born a programmer, so you need to find what you like and practice. The thing is, and this is very important, um, yeah, you use apps on your phone, right? You do that. Everybody does that. If I told you that the code that you were using was written by a programmer on his first day of work, would you use this app? And you probably think about it twice if you do that, because like you would like to probably work with something with people with code written by people who have experience. So we need to get experience. And in order to do that, we need to practice. In order to do practice, we can't really practice on the code of work. We can, most people do. But if you want to get better at that, you need to practice outside of work. So we call this deliberate practice. You actually practice. I'm going to learn something about programming here, uh, something that might interest you. So the more you practice, you'll be better at that. And like I said, it's skills. You do something more, you'll get better. You learn what works for you, what doesn't work for you. It's okay if something doesn't work for you. If somebody tells me, well, automated tests are not for me, I said, cool. It's great that you don't have any bugs. I'm very happy for you. But if they don't have any bugs, that's cool too. That's okay. They don't have to learn everything, but be aware that you need to try all kinds of things like writing tests or refactoring. Practice, try as much as you can outside of work. So when you get to work, you can actually implement it better.
Do you want to add something from yourself?
I really recommend, and this is not just from like I like this. I've done this a lot, and that's first of all pairing, doing pair programming or pair testing. Um, I told you that I was doing Agile since 2004. I was doing Agile without even knowing that it's Agile.
Yes,
Like
exactly.
I was managing a team of developers and testers, and like this was like we were very the project was very in a very bad situation, and the main tester, and the UI developer were always shouting at each other. And I said, okay, sit together, like tester and developer. I know that the tester was a biologist, didn't know anything about how software works. And the developer was a UI developer, he didn't know anything about biology. But they sat together and they created something that works because they were talking to each other and they were working on the same computer, and they conversed in the right language so both of them understand. So the UI was built and it worked according to what the tester said. This is what I expect. So having this kind of conversation, and we usually talk about pair programming or something like that, any kind of pairing that can have people together at the same point and discussing what they want to build shortens the time to something that is working. So that, and you can actually derive that from, take that to communications. I said everything's about people, everything's about communication between people, and that's a skill too. You can get a lot better than you are today. I was like, I don't know. I can't describe what I was like 10 years ago in terms of communication. So I practiced a lot. I said, this is what I want to do. Even like starting conversations with people I didn't know. This was something that was new to me, but I said, I want to get better in that. And I did that. And that was crucial to what I do today. So everything can be, you can say, this is an exercise. I want to get better. Yes, it may be risky because I didn't know what I didn't do that before. I don't know what to expect, but there is going to be some growth in that. And I think in the end, this is what we want to do. I will want tomorrow to know a lot better, to be capable to do a lot more than we do today. And I think that's the point of view I'm trying to reach, either programming or managing or whatever.
Okay. Jill, thank you for the interview.
Thank you.
And have a nice day.
You too.